Fifth grade into math, lesson 6.2. Represent addition with different sized parts. I can represent the sum of fractions with different sized parts using a visual model. Spark your learning. Julia runs through an obstacle course. She climbs a cargo net in 1/4 of a minute. Then she crosses the balance beam in 1/6 of a minute. How long does Julia take to complete both obstacle courses? Okay, so we have 1/4 of a minute, right? Okay, 1/6 of a minute, and then they want to know how long it takes her to complete both obstacle courses. Okay, so we have our 1 whole, right, guys? So 1 whole. Okay, then it takes her, so we have our 4th, right? Takes her 1/4 for this. Okay, and then what's the other part? 1/6, right? Okay, but real quick, what is a common denominator between 1/4 and 1/6? A 12, right? Okay, so if I wanted to break this up into 12 pieces, how much would I have to break up each little piece? Each like 1/4 piece. In thirds, right? Okay, so you need to make sure that these lines right here are kind of dark that we already drew, okay? And then you're going to faintly, so lightly with your pencil, make them into one, or make each piece into thirds. So now we have 12, right? Okay. So then if we would have broke this up into 6, okay, how many would we have to break each one of those pieces into? 2 pieces. Into 2 pieces, right? We draw just a faint line. Okay, so it said that she did the 1/4, right? Okay, so we're going to take another color, or you're going to lightly shade, I guess we should say, the 1/4 section, right? Okay, and then how much did she do for the balance beam? 1/6. 1/6, so we're going to shade one of those pieces. So total, how many 12 size pieces did we shade? So up here there's 3, right? And down here there's 2. So 5/12. So 5/12 of a minute, right? But then we also need to represent that with an equation. Okay, guys? So our equation for that would be 1/4 plus 1/6 equals, so we have to get our common denominator, right? Okay, and what did you tell me the common denominator was? 12, right? That's our least common multiple, correct? Okay, how did I get from 4 to 12? Times 3. What I do on the bottom, I do on the top. So 1 times 3 is 3. Okay, how did I get from 6 to 12? Times 2. I do on the bottom, I do on the top. So 1 times 2 is 2. And then that would get us our 5/12 because you add 3/12 plus 2/12, and that would get us 5/12. So on our line, we're going to write 5/12 minutes. Build understanding. Some obstacle courses include a rope climb. On his first try, Travis climbs 2/3 of the length of the rope. On his second try, he climbs more than his first try by 1/6 of the length of the rope. What part of the rope does Travis climb on his second try? Okay, or by his second one. So we have 2/3, right? The first time. And then the next one is 1/6 of what he did before, right? And then what part of the rope does Travis climb on his second try? So complete the fraction model to try or to solve the problem. Draw to show your thinking. Okay, so here's the full length of the rope, right? Represented by 1, right? Then it says he did the 2/3 that first time, and then the 1/6 the next, right? And they want to know how much it is for that second try since he went a little bit further, right? So are we adding, subtracting? Adding, okay. So one student used all 1/6 fraction strips. So basically, if they did 1/6, they would have to break this 1/3 into how many pieces? Two pieces, right? So to do, so this would be 1/6. And this would be 1/6. And then this would be 1/6, right? Okay. Another student used all 1/12 fraction strips. So who is correct and how do you know? Okay, so you could use 1/12, right? Okay, you just have to break these 1/6 pieces even into two 1/12 pieces to replace them, right? Okay, but which one should they have used? The 1/6 or the 1/12? The 6, right? The 1/6 pieces and why? Is that the least common denominator? Yes. You can use the 12, but would you still have to simplify your fraction? Yes. Okay. So the 1/6 pieces work better because they have the least common denominator between 3 and 6. So could you use only thirds to represent the sum? Explain. So could we use thirds? No, because you have to use the 6 because that is your greatest common factor, right? So you have to use 6 because that is actually it's the least common multiple, right? Okay, write an equation to model your solution. So basically, we did 2/3 plus 1/6, right? Yeah. Okay, so you can write this on your line, but I'm going to write it over here. So we did 2/3 plus 1/6 equals our answer, right? We had to get a common denominator, and we said 6 is our common denominator, correct? So how did I get from 3 to 6? Times 2. So what I do on the bottom, I do on the top, and 2 times 2 is 4, right? So 4/6 plus 1/6 equals 5/6. So what part of the rope does Travis climb? So basically on C, we only had to have the equation, right? Okay. Then we did our work for letter D. And so it would be 5/6. And what's our label? What was it up here? 5/6 of the length of rope. To make the obstacle course more challenging, the swinging rings are moved 1/2 foot farther apart. They were 5/8 foot apart. How far apart are the rings now? So they went 1/2 foot farther, right? And they were 5/8 foot apart. And then they want to know how far they are apart now. How does the new distance between the rings compare to the length of 1 foot. So do you guys think they're going to be more than a foot or shorter than a foot? Okay, so let's find out. Okay, so is this where we're going to get a common denominator? Yes. Okay, so are we adding or subtracting? We're adding, right? We're doing 5/8 plus, I don't know why I put that there, plus 1/2. Okay, so what's going to be our new common denominator? 8. So the first one's not going to change, right? So 5/8 plus, and then something over 8. So how do we get from 2 to 8? Times 4. What we do on the bottom, we do on the top. So it would be 9/8. So is that more than a foot? Okay, so it says how does the new distance between the rings compared to the length of 1 foot? So our new distance is more than 1 foot. Because, can we leave that as an improper fraction? No, we need to simplify it, right? So 8 goes into 9 how many times? Once. Because this fraction bar also means division, correct? Okay, so it goes in there once. 1 times 8 is 8. 9 minus 8 is 1. So, and you keep your same denominator, right? Okay, so draw a visual model to represent the situation. Okay, so we are going to have our 1, right? Okay, then we're going to have this into what size pieces, guys? 8, right? Okay, and then we said, so we have to color in 5 of those, right? So 1, 2, 3, 4, 5. Okay, and then we said 1/2 is also equal to 4/8. So we're gonna have to draw another 8, right? And then 1, 2, 3, 4. So how far apart are the rings now?
1 and 1/8.
Okay, so 1 and 1/8. Not foot because we're over, right? So feet. Okay, and then our how do we know? There's our work, right? So for understanding, number 1, Jane buys a new pair of sneakers. The heel height of her old pair is 5'6" inches. The heel height of her new pair is 1/12 inches taller. What is the heel height of her new sneakers? So we're adding, right? Because it gets bigger. Okay. So we already did our 1 whole bar, and then in our same purplish color, we did it into 6 pieces. And then we decided that in order to get what we needed, we had to do it in 12 size pieces, which meant we had to break those 1/6 into 2, right? Okay. And then she for sure had the 5/6, right? So we need to do, like we say, 5/6, so 5 of the big boxes, right? So that would be 2 of the 12th ones. And then how much of the next one do we need to say? Just 1 of them, right? So we got a total of what? How many 12 size pieces? 11 12, right? So let's do an equation to double check it. So we have 5/6 plus 1/12, and we said our common denominator is 12. So do we have to change the bottom one? No. So 6 to 12 is times 2. What I do on the bottom, I do on the top. So 10. So does that give us 11 12? Yes, so our answer is 11